When we were doing symmetry, even symmetry, and odd symmetry, we ran out of time while we were still in class, and we were supposed to do these problems as a classwork. And I said that this is going to be our homework. It's only 3 questions. If I give you this function, can you say if it is odd or even? Just a quick analysis on this. Usually, some examiners would say, is this function even or is it odd, without saying odd symmetry or odd or even symmetry. So just for you to know that when someone is just saying, is this function even, they are talking about even symmetry. Or when someone is talking about, is this function odd, they are also talking about odd symmetry. So for now, I want us to solve these problems and see what we are going to get out of this, or the solutions of these 3 problems. The first thing we said, we talked about even symmetry. And we said that, just a quick summary of this. If you have a function, and let's say you wanted to plot, you have a plot, for instance, you have a plot, this is your plot. Let me try and draw this plot. You have this plot, and of course this is y, this is x. So if you have a function here, let's say your function is like this one here, right? If you have a function of this kind, and this function this side is also of this kind, right? So if you can cut this graph here along the y-axis, and this side you flip this side over, if this curve here overlaps on this curve, then we say that function is even, or it has even symmetry. Another way to look into it, you would think of this, the y-axis, as a mirror. Suppose this is a mirror. If you were to stand here in this position and this is your mirror, what would you see on the other side? If you can see this curve, this piece here is what you would see if you were to stand here in front of a mirror. In other words, this side is an image of this side, and this side is an image of that side. That function is called even, or it has even symmetry. So that's what we talked about. And we said that, for instance, let me take another example here. If you have a modulus function, and you know a modulus function looks like this, and you can see that the reflection along the y-axis here, if you reflect this, or you were to stand here in front of this mirror here, this is what you would see as a reflection of this side here, or of this piece of the curve. So this function here, we said it is even, or it has even symmetry. Now, if let's say now you are not given a curve, because the curve is all about a reflection along the line y is equal to along the line x is equal to 0, or the y-axis. Now, what if now I don't give you a curve, I give you a function instead, like f of x is equal to some function, let me just say maybe square root x minus a 1, or something of that sort, or f of x is equal to x squared. How do you know that this function has even symmetry, or it is even? So all you need to do, you just plug in minus x in the function. If minus x, f of minus x, is the same as f of x, then we say that function has even symmetry. So that is all about even symmetry. You can check the more explanation on this. I'm just trying to give you a quick overview of this. You cut this, You take this side, you put it on top of this, or you overlap it on top of this side. If this curve here overlaps on that, then it has even symmetry. As you can see here, if you were to cut this curve here and you take this to overlap on top of this side, this line here would slip on top of this line there. In other words, this curve has even symmetry. Now, what about odd symmetry? So when we're talking about odd symmetry, we are also talking about odd function. So a function is odd, or it has odd symmetry. If I take minus x and I plug it inside f of x and I get minus f of x, then we say that function has odd symmetry. Now, this is just a mathematical representation if I give you a function. But if I give you a curve on the other side, I give you a curve here, and I say I want you to find out, is this curve odd or is it even? Now this is y, this is x. We said that I'm gonna give you a curve here, and I'm gonna say this is the curve, right? We said that if, let's say, this curve is a curve of an even function, or a function that has even symmetry. So how would the other piece look like? First of all, you stand here in this position, and then this one here is your mirror. So the y-axis is the mirror. So what will be the image that you would see in the mirror if you were to stand here and look at this mirror here? So the image that you would see, it would look something of this. Of course, my graph is not drawn to scale. So you have this, it will look like this if the function f is even, or it has even symmetry. Now, what about odd? So when we are talking about an odd symmetry means that if this function has odd symmetry, what I need to do, I'm talking about odd now. If this is a mirror, how would this curve look like? So first it would look like of this type, right? It would look like something of this type. Then, after you have looked at that image on this mirror, which look like this, then you take this side again as the second mirror. So you have a second mirror. So if I were to stand here and look at this curve here, what would the mirror of this look like? The mirror of this, the mirror image of this curve, or of this piece here in this mirror look like? So if you stand here, of course, in the mirror, this would look like something of this kind here. Of course, my image is not drawn to scale, but I'm trying to illustrate here that for odd symmetry, I have two mirrors. The first mirror is here, and then you get an image somewhere there, and then after that you have your second mirror, and then your final image should be here. So if you have this function such that this piece can be found from this one by taking two mirror images, the first one here and the second one along the axis, then this curve is called odd, or it has odd symmetry. Another way to look into this is, suppose that I know that this function here has odd symmetry. So if this function has odd symmetry, the other piece I should get from here by rotating this curve about the origin, rotating this curve by 180 degrees. So what we usually do, we draw a line that is going to cut this curve somewhere, and then that line is continued down there. Why are we drawing that line there? It's because we know that a straight line is 180 degrees. So if I were to rotate this piece here by 180 degrees, it will go here. This position here will be somewhere there, right? And this side here, it will be in this side here. So when you rotate this, is going to be something of this type there. So the same thing. So another way is, if I can get this piece here, let me make it red so that we can see what we're talking about here. This red piece here, this is the red piece here. Yes. So that if the one part, if you see this red piece, it can be found by rotating this piece by 180 degrees. And also this black piece here, it can be found by rotating this red piece by 180 degrees. Note that if you rotate this like this, it would be here. It will be the same thing. So two ways to look at it. First, look at the mirror along the y-axis, and secondly at the mirror along the x-axis. That's how you will tell if this function has even symmetry or odd. To look at this one, if it has odd symmetry or is an odd function. So that's all about the summary of even and odd symmetry. Now we have these nice questions here. These questions are saying, is this function even or odd? So let me copy it first. So this function, the first one, which is number one is going to be, so you have your f of x is equal to 2x cube divided by you have x squared plus a 1. Okay. Yes, and if you look into this function here, we want to see, is it odd, is it even? All right. Okay, I know the problem is saying this function has odd symmetry, true or false, but now we want to find out, just for first understanding what is going on, and then we answer this particular problem here. Now that we have that, I said that to find out if something is even, function is even or odd, all you have to do, plug in minus x. If you plug in minus x in this function, we're gonna get 2, and then you have minus x, and then you have a cube all over minus x squared plus a 1. Now all you need to do, plug in minus x where there is x, and then you evaluate what you are getting. Now minus x cube is the same as minus x cube, so this one is going to be the same as, remember that if you have minus x and then you have cube, this is going to be minus x times minus x times minus x, which is the same as minus times minus is positive, times minus is going to be minus x cube. So here you're going to have minus 2x cube all over minus x squared. Anything that is negative, you square it up, you're going to get a positive thing. So this is going to be x squared plus a 1. Now if you look into this, x squared plus 1 is there, 2x cube is still there, we only have this minus. Let's factor it out. So if you factor it out, you are left with x cube all over x squared plus a 1. So this part here is the same as the original function, which is f of x. So it is the same as f of x. So this simply means that f of minus x is the same as minus f of x. Now what does this simply mean? It simply means that f is odd, or f, I can say f has odd symmetry. So that's what this simply means. Now let's go back to the question. What is the question saying? The question is saying the function f of x has odd symmetry. Is it true or false? Therefore, the answer is it is true. So the answer to question 1, we know that we're just gonna say the answer is A, which is true. And then now we go to B. What about question number B? So if you look again, question number B, we have a function f of x is equal to 2 times the absolute value divided by x squared plus 1. And the question is saying the function has even symmetry. Now we want to find out, is this true or is this false? Now that we have that, let's look into it. We have number 2. We have f of x is equal to 2 times the absolute value of x all over x squared plus a 1. Now that we have that, we want to check if we plug in minus x in the value of x and see if we are getting a positive answer, negative answer, or neither. So if let's say I am plugging this minus x here, I will have minus x, the absolute value of minus x, and then here we're gonna have minus x squared plus a 1. Now let's analyze here. I know that in the denominator, if I have minus x and you square it up, you still get x squared plus a 1. Let's talk about the absolute value. Remember that if I have the absolute value of 5, the absolute value of 5 is the same as 5. Okay, let me just write a definition of this. So the absolute value of x is the same as, we said that the absolute value of x is x if x is greater than or equal to 0, and it is minus x if x is less than 0. What that's supposed to mean, the absolute value of 5 is the same as 5. The absolute value of minus 5 is the same as minus 5, which means we get a 5. So this absolute value is there to make sure that whatever we're getting here is a positive answer. So that's according to this definition here. I'm not coming up with my own things. Example, if you say the absolute value of minus 10 is supposed to be a minus 10, which is just a 10. So that's the meaning of an absolute value, which means that if let's say I have the absolute value of minus x, the absolute value of minus x is supposed to be minus x if minus x is greater than or equal to 0, and is going to be minus x if minus x is less than 0. Let us analyze. We are using that definition here, which means that this is going to be if minus x is less than 0, so this is going to be minus x if I am going to multiply both sides by -1 here. If I'm multiplying by negative, the inequality changes sign, so you're gonna have x is less than or equal to 0. So that's what happens. And then this side, I am going to have this multiplied by that is going to be positive x if x is greater than 0. Remember what I did here, multiply by negative because I just want to isolate x. So this. Now, when you are going back, remember that if x is equal to 0, it doesn't matter. You can have the less than or equal to, or the less than or equal to here can go this side or that side, because 0 is not an issue. It's not an issue because the absolute value of 0 is just 0. So we can have the equality here and there. If we remove the equality, can you see that this thing here is the same as that, which means that this is the same as just the absolute value of x. So this one is going to be 2 times the absolute value of x. Now that we have that, is that not the same as f of x? Let's just take a look at it while I'm still cleaning this space here. So that's what we wanted to analyze here. analyze. That's what we want to analyze here. So this, if you look into this, we have 2 times the absolute value of x, 2 times the value of x, absolute value of x, x squared plus 1, x squared plus 1. So this is the same as f of x. Therefore, our f of minus x is the same as f of x. So what does this supposed to mean? It simply means that f is even, or f has even symmetry. So that's how you answer question number 2. Now, let's look at question number 3. The function has odd symmetry, even symmetry, both even or odd symmetry, or none of the above. We want to choose that. Which one of these choices are correct? So we have our number 3 here. We have our f of x. F of x is equal to x squared plus x. Now, f of x, first we want to plug in f of minus x and see what we're getting there. So I'm going to plug in the value of x minus x, and then you square it up, plus in the value of x, I'm going to plug in minus x. And then the answer we are getting here, minus x squared, is the same as x squared. Minus x minus and a positive is just going to be minus x. Now, if you look into this thing here, this is not the same as f of x. So this one here is, I can say that this is not the same as f of x here. Now, we want to see if it is the same as minus f of x. So we factor out a minus here. We can say that this is going to be minus 1 times minus x squared plus x. So if we're factoring minus 1 here, so if I multiply a minus and minus, I will get a positive. Minus and a positive, I will get a minus. But still here, if I factor out a minus, can you see that this is not the same as x squared plus x, which is equal to f of x? And can you see that this is not the same as minus x squared plus x, which is equal to minus f of x? So this is not equal to that. What? Because there is this minus here, we don't have that minus there. Therefore, you can say that f of minus x is not equal to f of x, and f of minus x is not equal to minus f of x. What does this simply mean? Looking into this part here, you can conclude that f is not even, or you can just say f does not have even symmetry. Does not have even symmetry. And looking into this part here, f is not odd function. So this one is not even function. Let me add function here. And then this one is not odd function, because this is not equal to that. Therefore, f is neither odd nor even. Right. Let's go back to the question here and see what the question was saying. The question was saying f has odd symmetry. We just have shown that f doesn't have odd symmetry. F doesn't have even symmetry. Both even and odd, that is not happening. None of the above. So the correct answer here is going to be D, none of the above. So the correct answer here is going to be D, which is none of the above. So that's how you answer these questions of odd or even. Another question will come and say that, suppose that you are given a function here, a curve. Suppose you are given a curve here, and this is x and this is y. Now I am saying to you, we have this. This is wrong. Let me remove that. I'm saying that this piece here is given, is going up, is going that way, and you have x here and you have y there. The question now is saying, draw the remaining piece of f. I'm going to say this is f. Draw the remaining piece of this graph such that f is even. So if you want to draw the remaining piece of this graph such that f is even, what do you need to do? First of all, for even, the y-axis, you make them your mirror. So it's going to be your mirror here. And you are standing this side, standing somewhere here. If this is your mirror, what will you see in the mirror? Of course, the image will be seen as if it's on this side of the mirror. So this here is getting closer and closer to the mirror, and then it's getting away this side. So this is the image that you would see on the mirror. So you would see this piece here. That's how you would see if f is even. So that's the image for f is even. Now, if we are saying f is odd or f has odd symmetry, how do we go about that? I said that first of all, you have to look at your y-axis as a mirror, and then that's your first mirror. So you look at the mirror, and when you look at the mirror, what you will see a graph of this kind here. So this, this would seem like this, but it's going to be, let me use a different color. Okay, let me just use blue. It's going to be a graph like this. Let me not use dotted lines, because you're not going to see dotted lines in the mirror. You'll see a complete thing. So you're going to see a graph like this on the mirror if you stand here at this point. So you will see this graph like this. Now, standing here, this side, and this one is your mirror. The x-axis now are your second mirror. So when you stand this side, how will you see this function here in this mirror here? So this is your mirror. So of course on the mirror you will see this as if it's on this side. So this is gonna be going like this. Let me use a different color. I'm gonna have a green. This is bad. This is bad too. Let me try again. I'm gonna see something of this type. Why am I drawing bad things here? So it's gonna be something like this on the mirror. So the complete graph, if f is odd, is going to be, you look into this along the y-axis, you get an image that was here, and then look at the second mirror. This is what you were looking for. Again, I said the second way to look into this is rotating this by 180 degrees. So if you look at this is first quadrant. If you rotate the first quadrant by 180 degrees, it becomes the third quadrant. So you take this, it's gonna go here. So this here is supposed to be this after rotation. So this is how you manage these problems. I hope at least I've tried to explain this classwork homework problem, and thank you.